Okay, so we're live. Hi everybody, welcome to the TST. Today Satish is going to share with us his proposal for using PCECC as a sort of transition SDN solution for some of the legacy networks. So with that, I'm going to hand it over to you, Satish. Oh, and one more thing I forgot to mention, by the way, congratulations on becoming a module owner. And
Thanks. Yes.
We greatly welcome the help, because as you can see, we have a lot of reviews to go through, and the more I comment, the better. Okay, so with that, I'll let you take it, and you can start presenting. Share your screen and take it from there. Perfect. And I'll make sure you presenting to everybody here.
Sure. Oh, yeah. So you guys can see my desktop.
Yes.
Mm-hmm. Okay. Yeah, welcome. Welcome everyone. In today's TST meeting, we'll be discussing like how PCCC can be acting as an SDN transition solution for some of our legacy networks. Okay, so that we'll take it up in two parts. First part, we'll discuss about the overall what is PCE and what is PCCC and how it can act as an SDN transition solution. Okay, we'll take it as a first part. And the second part of the discussion will go with high-level design, which I want to discuss and get confirmation. So this will take it up as a second part in today's meeting. Okay. So the contents will be like initially we'll have PCE introduction. We'll discuss about what is PCE, and we have like how PCCC and what is the difference between PCE and PCCC, and how PCCC can be a SDN transition solution. And we see some few use cases. The key use cases, and we'll have the next phase. We'll have the discussions on high-level design, and we have identified some extensions required in the core modules or incubators. So we'll discuss like why it's required and what is the necessity for it. Okay. Okay. So coming to the PCE. Okay. So PCE is nothing but a path computation element, or it's kind of a function. Okay. So it's an entity. You can name it as a component, or you can also name it as an application, or you can say as a network node altogether, which is capable of computing a network path or route based on the network graph. And when we say network graph here, what we mean is the topology information plus some of the traffic engineering parameters we consider to compute the path. Okay. So and the path can be simple. Best effort, or you can say best shortest distance, or also you can say like by applying some few constraints like bandwidth constraints. Okay, so this is overview about the PCE. So I think we day-to-day life we can see like how PCE is helpful. Like you can take an example analogy I've given over here. So you have the Google Maps and you give the endpoints the Google Maps. So also you give a constraints like, yeah, I want toll-free, or I want to avoid the congestion, the alternate path, or you want the 4-lane or 6-lane. So all these constraints are given with the endpoints, and we derive out of the cost matrix. Like it gives multiple paths, and each path it gives the resultant cost, like for each of the path. So and as a input for this, we have a traffic engineering database that is just like a graph what we have. The Google server will maintain this graph, so we can have an analogy like this as a traffic engineering database. And also we can choose an explicit route path in path computation. Like we can choose like I want to explicitly go through this direction or this city or something. So those are you want to exclude that particular city in your computation. So all this is possible with the path computation algorithm or path computation element. So this has nothing to do with protocol. This is just an entity in the system. Okay, this is about path computation. Okay, so next we'll go to PCECC. Okay, so what PCECC is nothing but PCE as a central controller. So when you say as a central controller, it's when you talked about PCE, we talked about only about the computation part. Okay, so when you see as a central controller, we need much more than what is the computation, much more than that, not just a computation. Maybe we need to see how you can manage the network also, and how the labels are signaled. Basically, we want to use this for MPLS network. So we need to see how the label distribution happens, and how to avoid signaling, and how to avoid the distribution in the network, distribution control plane in the network. Okay, So this is what PCCC. Maybe I will explain the further slides. I have some slides to explain like how the transition happens between PCE and PCCC. There will get more idea about it, how the PCCC is being evolved. Okay, so the problems which you're trying to solve here is like using the legacy network. Current legacy network, the problems are, if you see the current legacy network, the complexity of deployment and maintenance is very heavy. So what I mean over here is like, since the computation is also distributed and we need a distributed signaling protocol. So for example, if you want to add a new computation logic, you got a new better computation logic, you need to upgrade all the devices in the network. So, and also if you want to create a tunnel, so each ingress node will have a computation logic involved in that, and again it is unaware of the other tunnels in the network. So by this you lose the edge over better performance, but the performance or optimization we lose it over here. And also it's not easy to add a service oriented to add new services or come up with the application oriented service to the existing network architecture. So anyway, this SDN as the basic principle does the programmability. So we will PCECC also supports the programmability. Okay, we'll see how it's being done. And also current architecture is the distributed IP or MPLS architecture. So we all know like what are the difficulties we have when you go for the distributed architecture in the network. Okay, so these are the current problems we want to solve. Yes, I agree that OpenFlow based SDN technology solves all these problems, and the only reason why we want to go with another flavor is like, yeah, we don't want to, one reason is like there are some customers who don't want to replace their devices immediately. So they want some transition solution where they want to use the current devices. They don't want to change any of the hardware or firmware in the devices. Okay, and they want to use the existing protocol which are already supported, but they want to make use of the SDN principles or SDN, the strength of the SDN over there. Okay, so this was the reasons like we'll have one more parallel, like how OpenFlow is there, we technologies is there, we can use PCCC as a transition solution. Okay. And if you see the use cases, PCCC network use cases, yes, it can be used in data center and the core networks, and so we discussed the SDN transition and the transport network. Okay, and the key text for the PCCC is like, yes, it can support source-based routing or SR we say, and multi-topology for network virtualization. In case of like different services can view it as a different topology, and path computation and LSP monitoring, like PCCC comes with path computation. And we also support IP plus optical. We can also support IP plus optical using PCCC. And it's also like we have hierarchy of PCE. This is nothing but the hierarchy of controllers. So this can be used to achieve the multi-topology or network virtualization. Okay, and yes, we have the network resiliency, like how our ONOS controller supports if any of the network resources goes down or comes up, and we have application aware smart TE. Okay, these are the key specs, and this is just one sample diagram. Like we have a network, I took a DC network as an example. So we want to connect between two DCs, and we have IP MPLS backbone between the two data centers. So PCCC can be used to set up the tunnel or path between these two guys to communicate. Okay. Okay. Coming to transition solution. Yes, if you see the left hand side, this picture was this network is the legacy network how currently is there, which doesn't use the SDN controller. If you see here, you have multiple 3 paths has been calculated here, but if you see here, each node which calculates the path, only the ingress node calculates, and the other guys do not have any knowledge about what is being calculated by the other ingress nodes, or no knowledge about how many tunnels exist in the system. Basically, there is no sharing. There is no distribution of this LSPs being created inside the network. Okay, so this is one of the big drawback, and the problems what we face in the real network because of this is like the LSP path taken completely depend on the order of the tunnel configuration. So what I mean over here is when I configure the first tunnel, maybe if you take bandwidth as a constraint, maybe the first 2-3 tunnels may be successful. Maybe the 4th tunnel fails because he couldn't find the respective bandwidth between those two endpoints. But if there is a central entity which knows about all the tunnels, so he can also do kind of optimization. When I say optimization here, something like we know about the garbage collection in the memory. So something like garbage collection where it periodically moves the tunnels between to squeeze the bandwidth so that the new LSPs can be formed. Okay, this is one of the use cases we have moving towards the central controller. Okay, so the next transition, first transition is the moving only the computation logic to the central controller. So here we call it as a stateful PCE. Basically, statefulness is basically he is aware of all the LSVs being created in the network. So he is more intelligent enough to take right decisions, and he can also have authority to automatically re-optimize the network. So your network doesn't goes down, but he re-optimizes the network without affecting the data path. Okay, so this is about only moving the computation to the controller, but still we have the signaling over here. If you see, this is the stateful PCE. So he talks about he only communicates with the ingress nodes. Okay, so to compute the path, he just calculates and gives to the ingress node, but later the reservation takes in this path. So it uses the reservation protocol. Again, it's distributed, and also you need to distribute the labels, local labels. Again, uses RSVP. So this is a reservation, resource reservation protocol is being used for this in case of constraints. Otherwise, the normal label distribution protocol will be used without constraint. Okay. So if you see here, only the computation is moved here, but still we have distributed signaling mechanism. It's not completely removing the control from the network. Still, we have the control plane, partial control plane exists over here. So the next one is we are moving towards the pure SDN, like where we have complete control logic with the SDN controller, that is PCCC. If you see it, like similar to OpenFlow, each device is connected to the controller, and controller has the capacity to distribute the labels to all these guys, so who are connected. And also when any request comes, he since he distributes the labels, we avoid the signaling part, and since he has the complete view of all the devices, the complete constraint management is considered within the controller. For example, if you take bandwidth, so bandwidth management is completely within the controller. He knows how much bandwidth each interface or each link has, so the complete visibility has. So there is no use of the control over here. He directly pushes the path over here, and he directly uses only the data path to push and pop the labels or replace the labels. Okay, so this is about the PCCC. This is how the PCCC, or we say like it's the SDN transition solution. Okay, so it's completely moving the signaling protocol as well as the label distributions and the computation outside the network. Okay, so here we have idea of supporting for G release. We are planning to support these three basic modes of PCECC. We'll support stateful PCE as well as PCCC modes. So we have three modes we are planning to support: basic, SRB, SRT. So the basic is just only about RS signaling we are removing, and computation, and also this is similar to RSVP but without T signaling. Basically here we compute the local path and local labels and distribute it along the path. Okay, the SRB is moving towards the PCCC with segment routing. So here we'll distribute the global labels as how the segment routing does, and we also calculate the label stack for the path, and we'll be pushing only to the ingress. So basically it is more towards the source based routing of segment routing. Okay, so these are three modes we are planning to support, and here I just give a comparison between PCCC based SDN versus other solution. So I took three things over here. One is IPMPLS without SDN, and we have OpenFlow based SDN, and we can see one more alternative as PCECC based SDN solution. Okay, so here the red part I mentioned as maybe the problem things, and it's app oriented service. Yes, existing network cannot support. And if you see new forwarding table and hardware or firmware upgrade, yes, the OpenFlow required for it can be achieved at abstraction, but still the performance is a key concern. So anyway, it has to be taken care at hardware level. So operators need to change the hardware. Okay, so this but with the PCCC, you can go with the existing hardware and the same protocol. So again, the signaling protocols we are needed without SDN. but other two cases, OpenFlow and PCC, is not required. And new protocol in the network is not required for PCCC, but for OpenFlow, the legacy system need to upgrade to the thing. And yeah, this is the other problems are like specific to tunnel setup. Yes, PCCC is very specific to this, but OpenFlow has much more capability beyond this one. Okay, so I'm not denying that part. So this is what I mentioned over here. Like we have other capabilities of OpenFlow, like ACL rules we can push, and push any of the flow rules into the system. Okay. And some of the use cases which we are customers or network service providers requesting is one of the use cases what they're looking at is the load balancing, and also they look at the key parameter of global optimization using the PCCC as a controller. So we have here like one of the key thing is we have load balancing. For example, the tunnel is being created between these two PEs, so PE1 to PE2. And we have two tunnels, one is the primary and the backup tunnel is being created, and we have a load sharing. Again, this sharing can be application aware, and it can be programmable, and it has good agility, like it can be changed based on the timings. Maybe the morning times you can reduce, or the night you can reduce, or in the peak hours you can increase, change the path where the bandwidth is more or something like that. We can alter it using PCCC over here. Okay. And also we saw about the global optimization, so they are also looking at the global optimization part, like it's something like they want to make use of the resources very effectively by global optimization with the given limitation. Okay, so by using global optimization technique, we can achieve that by squeezing or re-optimizing the tunnels based on the needs. Also, we can have a periodic optimization, like maybe the daily ones or weekly ones, kind of. It's again the implementation specific. Okay, so the other use cases we see like PCCC can work on multiple networks, like core networks and access networks and mobile networks. So if you see, like we use this advantage of PCCC, like to calculate the path across multiple networks. Like if you take our mobile network, it has to pass through many networks to reach it. So between the node Bs and to the other network, so it has to pass through multiple areas or multiple networks or multiple AS. So using PCCC, this can be achieved very easily. Like we can have multi-controller, like, and we can have kind of east-west communication is one way, or we can have hierarchical controllers, the other solution. So so these are this also one of the use case from the mobile network providers. Okay, so this is the just basic to give guys about like what is the PCECC and how PCCC has been considered as a transition, and how it's be like pure SDN where you remove the complete control plane from the data plane without affecting your data. Okay, so data path. So this is all about your PCE and PCCC. Okay, so now this we want to develop in part of Goldeneye. So this is my overall design, which initial design which I thought about. So I'll be explaining each of these guys here, why we need interaction with multiple core subsystems, and what is the use of as southbound and the apps which you are developing. Okay, so the path computation is the one of the app which you want to put it. Basically, we want to use the CSPF algorithm. It's a basic Dijkstra's algorithm, and we have a reactive path. This is for resiliency, so which keeps monitoring for any network events and alter the path. And we want to have service interfaces JSON as well as for the other apps. And we want to use the segment routing for SR based PCCC. So we use of segment routing in this aspect. Okay, so with respect to the dependencies, we have with the tunnel manager. Basically, tunnel manager, we want to use it to create the tunnel. Whatever the path has been computed over here, we want to push it to the tunnel manager, and the tunnel manager, using based on the provider, it pushes to the corresponding providers. In our case, it will be a PCEP. So we use PCEP protocol, path computation element protocol over here, to communicate with the network devices for this tunnel which you have been set up. Okay, So we give the tunnel information. Tunnel manager interacts with the corresponding provider, and this information pushed to the network and gets the response and update the tunnel manager with active or ongoing. So by this, the tunnel setup is okay. And again, the tunnel manager goes to the driver. I think for the fallback provider mechanism, since the devices has learned by BGP-LS, so BGP may not have the tunnel provider. So we need to have a fallback mechanism to push it to the using the PCEP provider. So we have a fallback provider dependency over here, and okay, then we use of label manager to allocate the labels or release the labels, and mastership basically for the ingress node. So to monitor whether ingress node goes down, if ingress node goes down, it's altogether the tunnel has to be deleted and notified. So for that reason, we need to have a mastership monitoring only for the ingress nodes for the tunnel or path. And with respect to flow objective, we want to push the labels. We want to use the flows. So we use flow objective to push the flows, and there can be we'll use the extendable treatment and selector for this. So we may need to define new extensibility for this to define the new selector and treatment. And also we want to use resource manager. This is resource manager is not the old resource manager. This is the new resource manager which exists in our system. We want to mainly use for bandwidth parameter. We want to use this to completely manage the bandwidth, to allocate, release, and all other aspects for each of the endpoints. And also, okay, with respect to the topology, yes, topology, initially we developed BGP-LS keeping this in mind to learn the topology. So this is we have done in EMU release. So here we learn the topology information about the link and device. So I put here TE just for understanding sake. We'll discuss about this in the next slide. So this TE I am thinking not to keep as a separate subsystem over here. I'm thinking of using the resource manager to manage all the TE parameters. So TE parameters is nothing but the resource like bandwidth, color. So planning to use register or all the resources when the device is learned and the link is learned, register all the device and link resources with the resource manager, and use the resource manager to allocate or release it. So T is just for your understanding I have put here, but there won't be any separate model of T over here. Okay, and yeah, coming to here, southbound is BGP-LS learns the topology. Basically, it's only learning about the topology and T informations. So after learning, it pushes to the link device as well as to the resource manager. It attaches the resources with respect to the device to the resource manager. Basically, it registers for registering purpose. And next comes the PCEP. This is again the communication protocol with the PCC, that is PC client, that is the network devices. So all the communications go for PC goes via PCEP protocol. Okay. So this also is already developed. So we may need to fine tune it a little bit to support segment routing and other extensibility or new draft update required in PCEP. Okay. So only that work is being involved here. Okay, so this is like what we have discussed earlier. PC application, the digital algorithm mainly we use. Also we have resiliency to compute and the interface for the REST and as well as for the external apps to compute the MPLS channel. And segment routing application, yes, we use this for global labels and adjacency labels assignment to the devices, and also to compute the label stack for the given end-to-end path. And we have tunnel manager. This is tunnel manager dependencies for PC app, calculate the path and take the service of tunnel manager to set up the tunnel. Also relies on the tunnel manager for distribution of this tunnel information to the ONOS clustering case. So we want to use this store for the multi-instance as well. Okay, and also the label manager, yeah, we discussed for distribution, and the new resource manager for basically for all the PE resources and other resource information about the network. And the mastership, yes, for the ingress device we need to know the mastership, and the flow objective to push the labels into the corresponding devices in the network, like global labels and adjacency labels. And the driver manager and the driver IMPL we use for selector and treatment extensions, and the driver pipeline and fallback provider for tunnel manager, and also for fluent extension model for projecting device and links as L3 device and L3 links. I think this is the new work, and we'll be using this projection modeling for PCE work as well. Okay, this is the basic things of device and links. I'll skip this part. Okay, so coming to the TE manager, yes, this we already discussed. So I am planning to use the resource subsystem to register the network resources. So what I mean network resources is like all the TE parameters like bandwidth, TE colors, TE metrics, SRLG. So only difference is here is like apps from the provider part, we'll only register it. Only for bandwidth we'll use as an allocation because it's a continuous parameter. So we want to also see continuously how it increases, decreases. So we'll use only for bandwidth to allocate it. So in case of color and SRLG, so there, we will not use allocating mechanism. We will only check whether it is registered or not. The reason behind is the same device can be used for multiple tunnels. So the current resource subsystem, I see like once you allocate it, this resource will not be allocated for others. So I will not be using allocation, but instead I will be checking whether it's registered or not for the parameters which is not continuous. Okay. And okay, this is what I discussed. This is two solutions we have for the TE parameters. One is when you learn about the topology, we have one solution is like we have separate TE subsystem, and solution two is like how I discussed, like we have new resource subsystem, have a mapping between your device ID and register the new resources to the corresponding device IDs. So I would prefer solution two instead of defining one more new subsystem, because I already see that other parameters, like other T parameters like lambda in case of optical is being maintained in new resource, and also the bandwidth is also currently being maintained. So maybe I need to add few further constraints into this new bandwidth system to support this. Okay. And one of the things which I want to discuss over here is like clubbing these two as a single providers. So currently, if you see, there are two separate providers over there. So I want to club this as a single provider. The reason behind is the devices are being learned by BGPLS scheme. So the scheme information about these devices and links will have the BGPS scheme. So again, we have a so we want to use the reason behind is when you are pushing the rules, BGP also as a flow provider, and PCEP also we want to have a flow provider. So in this case, since BGP is a scheme, I think flow rule manager will default push it to the BGPLS provider. So I want to avoid that. So that's what I was earlier discussed, whether we can have something like override providers. So the other solution instead of having override providers is like I want to keep a single provider generic for these two guys. So maybe here I can make a decision whether to use PCEP protocol, whether to use the BGP protocol based on the rules. So that was the reason I want to make it as club it as a single provider instead of having separate BGP provider or PCEP providers, two different providers. And yeah, the one more point I want to discuss over here is like the extensions required in the tunnel manager. If you see the current tunnel manager, as a support only to learn the informations from the network, like the tunnel informations. So there is no service interface given to create a new tunnel from the application point of view. So I think as an SDN controller, I think we should have a mechanism to create a tunnel as well in the network from the application point of view. So I think this we need to extend it. And I see there is no mastership consideration in the tunnel store. So the reason behind is like why mastership is required is like when southbound protocols like PCEP learns the tunnel information and gives the tunnel manager, internally the tunnel store generates the unique ID which is acting as a key for the tunnel. So it uses the ID generator to generate this, and the issue is like if we learn this from all the instances in the cluster. So for example, the ingress device is connected to multiple instances, so all the instances will learn about this tunnel information, and each one will try to push this tunnel information to the tunnel store, and tunnel store will consider each one as a different, and it will generate different ID. So instead of a single tunnel, it will generate n number of tunnels. So I think that is the problem which I see over here. I think one of the solution what I'm thinking is like use a mastership like how we have for the devices, and use the ingress device mastership to decide where to generate it. So based on that, you generate the ID over there and use that ID for that particular tunnel and sync with the other instances. So instead of distributing to all the guys to generate the ID, you can have the mastership node. And one more point which I saw is like there can be more than one tunnel between the same endpoints. So current design, I see like this is not considered like I can have the two tunnels between the A to B. So, but when I say A to B, again, when I create A to B, it goes as an update. So there is no mechanism in the provider service interface to tell whether it's really the new tunnel or you're going to update the new tunnel. Because the reason behind is again the tunnel ID which is generated inside the tunnel store. So this also needs to be extended for this. So yeah, so this is from my side, like this is what overall solutions I'm in design I am thinking about. So I want your guys like opinion, like whether is it in right direction or you guys have any suggestions over here or any questions?
Yeah, no, this actually looks really good. Looks good to me, Satish. So I have some questions. Looks like some of those were answered through the course of the presentation, but I still, just to be sure that we're on the same page. For segment routing, so I agree with, okay, a couple of things. So I agree with the fact that we should be trying to use the resource manager, so that's great.
Okay.
I also saw that where we sort of left the IP topology application, right? The idea here is to redirect it to use the drivers for projection of those small objects. So that's great. I agree with that. Okay. In terms of segment routing, this is going to be a new application, or are you planning to integrate with the existing one? I just wanted to make sure.
Yeah, I got it. Your question. I have checked the code of the current segment routing. So what's happening with the current segment routing is they have the complete the labels has been completely distributed from through the network config service. Okay, yes. That is the first point. And next, what I see is like in the segment routing app, which is existing in the current for CORD. I think it's for CORD thing. So there I see it's more towards about how they push this, more about the group tables are involved in that. I think for in our case, there is no group tables and those aspects doesn't come into picture because what we need is just a label stack and distributing the labels to the corresponding devices. Okay, that's very simple, straightforward. So either I will have a separate component or maybe I can combine with maybe one of the services or under PCE. So just for understanding's sake, I put it as a two different boxes over here. But I need to check whether it can be a two different component altogether or whether PCE himself can handle it internally as a feature.
Okay, no, that's fine. It was just a question. I mean, I didn't have a preference. It was just for clarification.
Okay,
I don't see a problem with having, applications that do similar things but slightly differently. That's really not an issue in my view. Okay. So the things that at least I noticed that the changes you would have to make would be to the tunnel manager to be able to similarly support the fallback provider mechanism. That should be straightforward, right?
Yes.
In terms of the bundling together the BGP and PCECC providers. So I think that makes sense. So you can do, I guess, a couple of things here. You can either bundle them together, or you can expose some of the functionality through the fallback providers, because BGPLS discovers devices and links and would project them upwards to be IP related, right? L3.
Yes.
Then any operations that flow to those devices to be able to control them either using flow objectives and ultimately flow rules would then be funneled through two layers of drivers. Well, first of all, the pipeliner driver to be able to translate into flow rules, and then through the flow rule subsystem, it would have to go to the flow rule provider, which in this case you could either, I guess, if you bundle it, you would go to your BGP provider,
Correct.
Or if you don't bundle it, if you use the fallback provider, you could just send it to basically to PCEP drivers.
Thomas, small issue over here. The fallback provider, what my understanding is, like, if there is no provider over here, it will go and for the fallback provider. But in our case, BGP also have a flow provider, and PCEP also has a flow provider.
Sure.
So if both as the flow provider, still the fallback provider holds good.
I see. So you already have, okay. So I didn't realize that the BGP-LS stuff had its own flow provider already.
Yes, yes. Okay. Yes. That we added for this flow spec, I think.
Oh, the flow spec. Yeah.
Yes.
Okay. Yeah. So the BGP flow spec stuff that still needs some addressing, but that's a separate subject. We can tackle that offline. Just as in short, we just need to avoid sending opaque data through.
Sure.
Bypassing abstractions. Okay, so yeah, so it looks like in your case then it would make better sense to provide a bundled provider, so that basically anything discovered through BGP-LS would then be funneled through PCEP in this case.
Okay.
A way to program the tunnels and program the flow rules.
Okay, and Thomas, one small point I want to highlight over here. With respect to PCE and BGP, if you see ODL, it's a single bundle. So I'm not sure whether this will have any violation of, like, if somebody from ODL sees, if I club this together, they may see that I borrowed from ODL. So I want to know, like, whether is it okay, or we can think about something else.
Wait, what do you mean? Hold on a second. Can you repeat the question? ODL? What was that?
Yeah, in ODL, if you see, they have bundled this PCEP and BGP as a single package. Okay.
Yeah, that's a tech.
Yeah, that's one. So I think they also have the similar problem. I think that may be the reason. I have not gone depth into the ODL side to check what was the reason why they have a single bundle. But what I see is they also have something called BGP PCEP as a single bundle. They don't differentiate between PCEP and BGP as two separate entities. So when we put the provider as a BGP PCEP provider, so if someone from ODL sees it, they may think that we have borrowed, even though they don't know the internal details. At the first look, they may have a feeling like something we borrowed from ODL.
Well, we can certainly borrow the concept from ODL.
Okay.
I don't think that's an issue, as long as we're not borrowing any code or something that should be perfectly fine. It's just a approach, right? I mean,
yes, exactly.
Yeah, I don't see a problem with that. Now, in terms of to facilitate the distribution, so we can talk details about the specifics of the packaging. It might be a good idea if you preserve distribution of your BGP only providers, and at the same time allow you to assemble an application that provides BGP PCEP combination.
Okay.
So we've done similar thing with our OpenFlow. You notice how we've broken things apart into basically OpenFlow base, and then the overall OpenFlow providers are basically like a hierarchy of applications that depend on each other. You could choose a similar approach here, where you have a base BGP set of base providers which provide just device discovery, and then the BGP providers add the additional flow control mechanisms, and then you can do a similar thing on a PCCC side. So that's a detail. There should be a way to basically not having to duplicate any functionality, and at the same time be able to preserve ability to choose one form of distribution versus another form of distribution. That should be simple.
Tom?
Okay, sure.
Yes.
We have some questions here from ONLab.
Yes.
Tom, you want to?
Oh, yeah. So I was just, my take on this is the explanation makes it much more complicated than it needs to be, and you should really try, it's this legacy thinking that just really confuses everything. My humble suggestion is that you start thinking in kind of an SDN way, and really don't try to, recreate all this legacy stuff and create a bunch of sort of mechanisms in ONOS that are basically kind of re-implementation of MPLS's distributed protocols. It's completely the wrong way to think about it, and it's very frustrating to hear this And a much better way of thinking about it is the SDN thinking, and all this really is using PCEP from MPLS as a control protocol. And once you realize that, it simplifies everything. And there's only one question which you have to ask, which is how is traffic classified and selected? And once you realize that that's the abstraction, then you have an SDN abstraction, then your design completely changes, and instead of making an MPLS specific design, you actually create an SDN design. And once again, so tunnels are really not the right abstraction. You should use an SDN abstraction in ONOS, so use the existing flow objectives and paths. Those are the right abstraction. You should also think of sort of the generic resource management idea is a good one, and you should sort of think about resource management in general and about what an operating system should do and sort of what the resources are, and don't think of them in an MPLS specific way, but think of them in a generic networking kind of way, and think of a solution that will work with both an MPLS control protocol and with an OpenFlow based control protocol. And I mean, I've said, in some sense I like this because it's something I've said for years, which is that you can do a lot of what OpenFlow does with SDN using an MPLS control protocol that can program label switches, which is good, right? And so the right way of thinking about it is to bring MPLS into the SDN fold, not just the sort of complicated thinking of, oh, we have a dozen existing MPLS protocols that we need to re-implement somehow. Oh no, that's just insane, and it just really taints your thinking and sort of like overly complicates things in a really horrifying way. So I really want to think. My recommendation is that you really just simplify this as much as possible. And all you really need to do, as far as I understand this, is to have a driver that speaks PCEP so you can program label switches. And you should really think about creating that and integrating it within the existing abstractions of ONOS and using the same abstractions and the same interfaces for anything that has to use MPLS, and using the flow objectives and flow rules. The existing ONOS abstractions and mechanisms should be used by all applications that have to talk to MPLS switches. And you're sort of, instead of creating this this immensely complicated vertical API and set of subsystems for this one application, you should try to create a simple generic mechanism which can be used by any application that wants to talk to MPLS switches. So use the simplest implementation in the ONOS core, simply create a PCEP driver that can be used by flow objectives, and it's kind of game over at that point. If you need resource management, make generic resource management that can be used by OpenFlow or MPLS or anything. So don't think about tunnels, it's just the wrong way of thinking about it, and try to find the common abstraction to use it.
Hey, Bob?
Yeah.
I mean, those are good points, but I just want to point out, so the resource manager is generic, right? That's the one that we're using for a number of other things. That holds generic resources. In terms of the flow objective, you already mentioned that. Whether we use drivers or providers, that's a minute detail. So that's already being sort of taken care of.
So
abstraction.
It's about splitting the PCEP and DPLS into separate providers. Like it's different abstractions. It doesn't make sense to put it.
No. So that's but that's on the south. It's nothing. This is not something that's visible to the application whatsoever. It's just basically it's a registration of southbound code to accomplish certain objectives.
Yeah.
So effectively drivers there.
Yeah.
Right?
What really bugs me is this sort of tunnel manager. I think it's the wrong way of thinking about things.
I didn't hear what you said. Is what?
The tunnel, I mean, okay, actually you can continue, Thomas.
Okay, well, so the label manager is essentially just, again, generic label manager. It can apply to MPLS labels or other labels. And the tunnel manager is basically just a mechanism for keeping track of isolation primitives. Now that's one thing that eventually we may want to revisit, especially as intents should be able to provide isolation primitives. But in the meantime, until we have that, I think that's again something that's decoupled from specific tunneling technology like VXLAN and VGRE or VLAN or whatever. So these today are generic existing constructs. This does not introduce any new subsystems.
Yeah, well, I think I'm kind of not happy with thinking about it as tunnels because they're not really tunnels. they're actually much closer to flow rules. So I think you should, and as you mentioned, what you're really creating here are paths which are much closer to intents, and so you really should be able to say, just look, all this traffic coming out this port, I want to tag in a certain way, or I want to, I don't know. I think the abstractions just seem wrong here. Like, if you want source routing as an abstraction, then you should add source routing as an abstraction. If you want paths as an abstraction, you should have paths as an abstraction. But this tunnels seem much more like virtual links, and they aren't the right abstraction for this application.
Well, I'm not sure, actually. I agree, because if you look at so clearly flow objectives and flow rules, right? Or let's just people flow objectives. Clearly, they're sort of the most fundamental objectives that you can have. They're pipeline dependent, and allow application to control behavior of a specific forwarding, filtering behavior of a specific device, which is great. However, the whole reason we have intent subsystem is because we recognize that applications may not want to be concerned with the device-centric abstractions. They generally just want to. They might want to be concerned with intent-centric abstractions.
Exactly.
So I agree sort of with network-centric abstraction. So I agree that as far as the sort of the legacy meaning of the tunnel is maybe not the right abstraction, but let me explain why it may not be a big deal, at least in the interim. Because with intents, we're fundamentally reconstructing the network-centric equivalent of an isolation primitive or like a tunnel using the flow objectives. That's the whole idea, is to get to that point. So it's a useful construct. Now, in this particular case, the tunnel construct here is bypassing. In this case, it's really literally because it relies in some cases can rely on native tunneling constructs that the networks provide already, the legacy networks provide. So it seems to bypass the flow objectives, and I think this is probably where you have some issue. And I get that. However, in the long run, it's still a very, very useful primitive, and we're essentially rebuilding it using our intent subsystem. And so, in the long run, I think what we probably, once we have the intent-based tunneling primitives figured out, we might be able to create an overall abstraction of a tunnel, essentially, which makes it completely invisible how the tunnel is accomplished. But as a primitive itself, I think it's a very useful one, and I don't see any problem with this application relying on it.
I think paths are the right abstraction. So to say, look, I want this, I want this traffic to go across this path, and if you want to have, I don't know, if you want to program MPLS rules, that seems very much like flow objectives and flow rules. And not at all like tunnels. So it just seems like the wrong abstraction. The right way of thinking about it is, like I said, is kind of SDN thinking of saying, well, look, think of them as flow rules and integrate them into our other abstractions.
But okay, well, but long-term. Basically, long-term picture is that we will be able to essentially do that, right?
Well, yeah.
Because that's what I described, right? The label management is basically just like essentially resource management, and the tunnel management can essentially over time, as the intent subsystem evolves and reaches version 2, might potentially be able to manage tunnels directly through the intent subsystem.
Yeah, they're not really tunnels. I mean, that's the thing. It's
isolation primitives.
Irritating me. It's not even isolation primitives. I mean, they're paths in the network. They're traffic paths, and the only difference between one that's the implementation is, is something that probably should not flow all the way up to the application. Although, if it does, it should be sort of abstracted nicely and in a way that can sort of work potentially, lead to an application that works with OpenFlow and with MPLS and with something else rather than just being wedded to a particular protocol. But even if it is wedded to the particular protocol, it should still use the same APIs. And so, sort of creating a separate, I don't know. I don't like how the I think I agree with what you're saying, that eventually the tunnel manager really should go away and go into the intent subsystem. Well, probably, at least for proactive tunnels that are created by created by ONOS or by applications.
Yep. So I think in the interim, I think this is. I mean, I think this. I like this. The reason is because it seems to make effective use of the existing mechanisms that ONOS currently has. Mostly focuses the work on a south and on a north and at the application layer. With clearly some enhancements and adjustments or evolutions of the core subsystems, that's perfectly fine, like the fallback provider for the tunnel manager and enhancements of the types of resources that can be tracked by the generic resource manager.
Yeah.
So I think it's good. What is the? Sorry, Bob. Do you have another question?
Yeah. I think what you said is right. To try to isolate it as much as possible in the southbound and the northbound, but I still think, and then hopefully evolve the middle so that it sort of has a better set of abstraction, doesn't have weird kind of abstraction layer violations. But I also am concerned with sort of at the top that I think you should try to make sure that MPLS-based apps like these two, this path compute service and segment routing, that they use the same abstractions, right? And that you don't create the same abstractions and the same APIs. You don't create a new set of abstractions and APIs for each.
Yeah, but it's effectively using the same arsenal of techniques and services that segment routing is using today.
Yeah.
Portion of it. Huh?
That wasn't entirely sort of clear to me, but it really should. Like they should both use basically MPLS. In my opinion, they should both basically use MPLS flow rules or flow objectives, depending on how it works. But because basically at the end of the day, they're saying everything coming in with this MPLS tag, I want the following things to be done to it, either push or pops, and then I want to send it forwarded out this port, right? That's absolutely a flow rule, and that's kind of the flow rule subsystem or flow objectives. And the only difference between OpenFlow MPLS versus this is PCECC MPLS is the control protocol, but they're really doing the same thing. Actually, OpenFlow MPLS has, as far as I understand it, has one advantage, which is that it can do sort of advanced traffic classification, which although I'm a little bit unclear about how MPLS does traffic classification in general. It's obvious that it can do port and label based, but the question is sort of how are the labels assigned at the beginning based on sort of the traffic content. That's something that's always confused me, so I don't understand how that works in this instance. But I think sort of instead of trying to sort of wedge SDN into a square SDN peg into a round MPLS hole, I think we should be trying to do the reverse. Integrate MPLS into the SDN sort of ways of thinking and framework, and make it so that we could have a generic mechanism that could be used by any application, not just by one application or two applications.
Sure, but I think I would treat this separately. So, given the fact that basically this proposal is using actually pretty much everything that it uses is existing in a core today, and so really your comment, Bob, is on how to evolve the core abstractions.
Yeah.
And less on this application, right? So, just to be fair to Satish, what I would suggest is that we maybe create a set of tickets and to track and and maybe initiate work on moving the core network abstractions in that direction, and then let this application sort of go with what it needs to be able to do in the interim. I think that should be perfectly fine.
Okay. Okay. So, Thomas, you mean to tell that instead of tunnel manager, we'll be having an abstraction with intent framework?
So for long run. So today you have a tunnel
Okay.
manager, right? Already.
Yes,
So
yes.
I would plan on using it. How you're planning to use it?
Yeah.
I think it's safe to say that in the long run, the tunnel manager is exposing is providing access to native type tunnels down on the bottom, right? Now, intent framework is going to provide access to isolation primitives / tunnels, which can be accomplished through flow rules or through other mechanisms. And so we will have two northbound entities claiming to be the same thing, and so that's clearly ripe for some level of consolidation. But I think we're looking probably a couple of releases down the road, so I would not be terribly concerned with that right now.
Okay.
So for your application, I would probably leave things as they are right now. Just proceed on this.
Okay.
And yeah, I would just go with that. And I think, as we were discussing before on whether to use the fallback provider or bundle providers, probably sounds to me like the combined provider is probably a better way to go, at least for now.
Okay, okay, I got it.
I have a question in general about the whole protocol. What's the performance of this whole system? What would it be the performance of after integrating the system? So if we run a network with ONOS and this system, what would be the performance of that network?
Yeah, actually, I really did not thought in that direction, like how much performance will improve or degrade. So what I see over here is like how controller can be used over here using PCCC as a solution. Maybe like on the floor, maybe I'll check like what will be the impact, because we are going to use our existing network, current network, what we have like Huawei devices, we are planning to use it. So I'm sure that I'll be getting the figure out like after moving towards this, what will be my exact end-to-end performance. So only one thing which I see as an issue over here is like the bottleneck with the controller having the computation. So all the ingress will, all the computation happens before it was distributed computation, like all the ingress computes, and now it's all comes to the central controller to have a computation. Again, it's again the like the factor we need to consider, whether you want the performance or whether you want about the optimization. So again, it's a trade-off lies there. So maybe like on the go, maybe like by the end of G or sometime, I'll be able to measure what is the impact on the performance. So I do agree that due to the computation, there may be a difference in performance. But again, when we go for distributed architecture, again the computation is distributed. So I feel like it again depends on like how many instances we come up, how many nodes we have in the cluster. So it goes in that factor.
Yeah, I agree. I mean, even if you didn't have, clearly it's going to be more it's more decentralized when it's happening on data plane. However, then it also goes with the increased need for coordination, which is far more latent than in any computation is going to be. And given the fact that the ONOS nodes or the servers that ONOS is going to be running on are likely to be far more capable than any CPU than you have on a switches, I'm not thinking that there should be any bottlenecking in terms of at least the control type processing and control level traffic. Actually, control traffic should diminish in my view.
Okay.
I have a question actually, following up on what Andres said. What's the relative performance of using PCECC to program MPLS rules versus using OpenFlow?
That's a good question.
Okay, I don't see I don't see any see, that's what I mentioned earlier, like whatever PCECC here, PCECC or PCCC you're doing. Yeah. So I see only the one difference, or is the only the protocol is different.
Yeah. Okay.
There we use OpenFlow protocol, here we use PCECC protocol. So apart from these two, I see whatever the OpenFlow network takes care, everything is being handled in PCCC as well. So it's only about whether your hardware supports or not. So just only for the cases where your hardware doesn't support, we go with this PCCC. If your hardware supports well, we can go with the OpenFlow.
Yep.
So,
yeah. There's two.
Oh, go ahead.
No, go ahead, Bob. Sorry.
I was going to say that brings up so you didn't really answer the question, like what's the relative performance of using one control protocol, the PCECC or PCCC versus OpenFlow for the southbound. I think that'd be a really interesting question to answer. And another thing just to think about is it'd be great if your application could work on OpenFlow-enabled hardware or legacy hardware, right? And so that's something to keep in mind.
Sure. And seems like it should be able to me.
It should be able to, yeah.
And maybe the thing that Bob is asking, it's doable because if the Huawei switches that you have on the network that you're managing right now are OpenFlow enabled, you could do a performance benchmarking right now, and then after you switch to your new application.
Sure. So I think right now, if I may speak on your behalf, Satish, so I think there's two levels of comparison, right? How does PCEP/BGP relate to OpenFlow? And that's certainly a valid question, but I think that's not the one that at least Huawei is currently concerned with, because they're interested in being able to use the legacy hardware, so where they use the use of existing protocols. So there, what Satish answered basically is comparing the use of the same protocols in slightly different contexts is not really going to matter too much, because it should be comparable because you're still using the same protocols, and most likely it's the use of those protocols that is the limiting factor rather than the computation or how you assemble the path. Mm-hmm. So there you have a more of an equal baseline, right? Do you use PCEP like this or do you use PCEP like that? And most likely it's going to be very, very comparable. And it's a different question than comparing performance of OpenFlow versus of another protocol. I mean, it's valid. That question is valid in other contexts, but I think in at least it's not pertinent to Huawei's objective here.
Sure, it's something that I'm kind of interested in because it tells you it will affect the performance of the application. In particular, it'll affect how sort of reactive it is to changing network conditions.
Absolutely, yeah. Oh, okay. So I mean, unless there's some comments or suggestions for sort of augmenting the approach, I mean, I know Bob, you had some, but I think it's fair to say that those could be tracked on a more long-term basis and really should be attributed more towards evolving the ONOS northbound API.
Yeah, my feedback for Satish is, the way you've explained it probably makes a lot of sense for people at Huawei who are used to existing legacy MPLS, but I might suggest that you consider consider another approach of explaining it in terms of sort of SDN sort of abstractions and thinking. And in that framework, what you're doing is you're adding the ability to use, as I understand it, sort of use MPLS's PCEP as a southbound control protocol, which actually sounds like a kind of useful thing to do and might have applications beyond just your app. So sort of maybe thinking about it in that way as well will make it something that might be sort of appealing and interesting to people who aren't necessarily interested in your specific application.
Yep. And a good test of this and of what Andrea suggested would be to kind of think, can you decouple completely the work that's happening in the providers from the one that's happening in the application layer? So like what Andrea suggested, could you run your application on top of, let's say, an OpenFlow network entirely? And if you can, then that really indicates that you have a really, really nice decoupling of these concerns, right? Because you really, the application is dealing with existing constructs, labels, flows, tunnels, and it's completely unaware of what's happening down in the southbound. And exactly. That's a really good thing.
I agree.
Yes.
Right. So otherwise, it looks really good to me. So presume that you will sort of assemble a plan and sort of actions and for addressing this as part of the Goldeneye release, right?
Yes, exactly.
Okay. Okay. Sounds great. And also, on the side, I may ask you for some help on a BGP flow spec area there too.
Sure, Thomas. Actually, I have not checked that code. Actually, since there was some different in plan internally, so today I had an internal discussion with the team. So I think there are few things which needs to be addressed. That's what I sent him. And tomorrow I'm starting with the more detailed review, because actually in design also I was not much involved with that flow spec as I was busy with the PCE part. So yeah, I'll be looking in that aspects. We already had a discussion today. So I have seen your comments today. I've gone through your comments as well. So I'm aware like what is going on. So tomorrow I'll have a look on that. Maybe I'll have a discussion. Then I'll take a call on that.
Sounds great. And I was thinking that would be because some of that work is happening in the application source tree. I was thinking of adding those areas to your module owner responsibility.
Okay. Sure. Yeah. All right.
All right. Well, this was a good discussion. Nice job, Satish. Thanks.
Yeah. Thanks. Thanks, Thomas. Thanks, guys.
Feedback, Bob, and everybody.
Sure.
Thanks.
Yeah. Thanks, guys. Yeah.
Bye bye. And again,
thanks,
Satish, for staying late at night for you.
Yeah, that's fine.
Okay.
Thanks, everyone. Yeah. Good night. Bye bye.